So we will work on the question on page 30 of your notes today. It's on contingency table. So this question, where it's talking about the table shows information about colors of the car owned by 100 drivers, classified by the sex of the drivers, male and female, basically testing whether there is an association between these two variables. That is, whether there is an effect of the gender while picking or choosing the color of the car. So we will start with the table that they have given us and do all the necessary totals. So that's total male 30, female 70, 18, 22, 18, 32, 10. Grand total is 100. Okay, so we know by now that to do that hypothesis testing, we need to have expected values and observed value. So this is our observed value. We need to find the expected frequency in each category. So assuming that our null hypothesis is true and there is no association between these two variables, what it means that they must appear in the same proportion. Okay, so to do that expected frequency, for example, if I am to figure out the expected frequency of a male picking a black car, what you need to do is look at the total of male, which is 30, and times it by the proportion of the total of black cars divided by the total here, which is 100. Now we can easily do that the other way around because we are assuming that the proportion is same. So we can say, let's have a look at the proportion of total black cars multiplied with the proportion of male in the population. So 30 over 100. And both ways will give us the same answer, which is 5.4. So it's up to you which way you do it. But we have to do that for every single category. So now for red, I will do 30. I'll just show you a little example again. Times it by the proportion of red, which is 22 divided by 100. So if I quickly do that, so that's 30 times 22 divided by 100 and 6.6. And you do that for all the categories here. Make sure you are checking the work in your calculator. And also one thing you should check, that all these values do add up to 30. All these values do add up to 70 because what you want is 100 as your grand total. Okay, so that's your expected frequency done. But we know that we always combine them, and that is why if you look at this table here, we have got 3 and 4, and that is less than 5. So here we are going to combine white and yellow, and that gives you the new table of observed value here, 6, 6, 11 for silver, but combining white and yellow gives you 7. So this is your observed value after combining them. So the total is still the same.